Alright, now we're looking at the third different type. So the first type of problems we had, look at the horizontal asymptote. It was 0, 0, 0. Here it's not 0, it's 2. It's 1. It's 1. It's not 0, other than 0. Here, this is the third case and the most awkward. If I factor this, isn't that x plus 1 into x squared minus x plus 1? Don't you take an x out, x plus 2? Vertical asymptote is where the denominator equals 0. That is x equals 0 or negative 2. 2. When we look for the horizontal asymptote, if the degree of the top, if this term is higher than that, then it doesn't work. I need to use long division, and I always take the quotient. That's always how you do it. There's no way around it. I know you don't like it much. If I take x cubed plus 1 divided by x squared plus 2x, x cubed divided by x squared is x. X times x squared is x cubed plus 2x squared. Subtract, change both signs. Negative 2x squared divided by x squared is negative 2. The good news, I'll stop right there. That's all I want. This is no longer a horizontal asymptote. It's an oblique asymptote. Oblique or slant. You could call it either way. It doesn't matter. You could just call it horizontal. For me, it doesn't matter. So, a horizontal line is a line running left to right. An oblique or slant line is line that's not horizontal nor vertical. That means it has an angle. That's from geometry, by the way. So, you want to call this oblique, you want to call it slant, it doesn't matter. Stick with oblique, I guess. 3. The y-intercept, that's the easiest of them all. Replace x by 0. If I put a 0 right there, that's a 1. But if I put a 0 in the denominator, 1 over 0 is not allowed. That means that's not going to happen. And 4. X-intercept. Where does the top equal 0? The top equals 0 only at negative 1. Because I know this doesn't have a solution in R. Alright, let me put what I got. I got x equals 0. There's x equals 0. X equal negative 2. So, negative 1, negative 2. That's a vertical asymptote. Now, the horizontal is not really horizontal. It's y equal x minus 2. Go down 1, 2. Rise 1, run 1. Oh. I gotta rescale it. Okay. Negative 1, negative 2. Rise 1, run 1. You know what? I'm gonna rescale the whole graph. Okay, so here. So, x equals 0 is right there. X equal negative 2, I'm gonna say negative 1, negative 2 right there. And y equal x minus 2, negative 1, negative 2, rise 1, run 1, rise 1, run 1. There it is. Number 26. I'm gonna factor the top and the bottom. That's x plus 2 into x plus 1 over x minus 1. Vertical asymptotes. Domain x cannot be a 1. I want to say horizontal asymptote. Again, I'll let you slide if you say horizontal asymptote. You're supposed to say slant or oblique. Long division. And I only want the quotient. I don't care about the remainder. By the way, if you were to use this on every previous cases, that would have worked. I just want that. Y equal that, and I'm done. So take x squared divided by x, that's x. X squared minus x, subtract. 4x divided by x is 4, and I'm done. Again, I don't care about the rest, just the quotient. 3. What is the y-intercept? Where does this graph cross the x-axis? Put a 0 in for x. Don't you get a 2 over negative 1, which is negative 2? How about x-intercept? Where does y equal 0? That's when the top equals 0. And I notice I have two values for this problem. So I'll make more space. I have a negative 2 and a negative 1. X equal 1. That's the only vertical asymptote I have. Y equal x plus 4. 1, 2, 3, 4. Rise 1, run 1. The graph must pass through its intercept. Oh, I didn't put the intercept in the previous problem. This graph only has an intercept at negative 1, 0. Pretty good. There it is. Here, I have 3 of them. I have one at 0, negative 2. Negative 2, 0. And negative 1, 0. Almost done, you guys. Almost done. 3 more to go, I think. 4 more to go. Alright. How about number 30? If I wait, did I just do number 30? No. If I factor the top, isn't the top x minus 4 into x plus 3 over x plus 1? 1. Vertical asymptote x equal negative 1. That's the domain. 2. Horizontal or oblique asymptote or slant, it doesn't matter. Y equal, and again the degree of the top is bigger than the bottom, it's long division, and I'm only after the quotient. So if I take x squared minus x minus 12 divided by x plus 1, x squared divided by x is x, multiply. That's a remainder, so it's y equal x. 3. Y-intercept. Replace x by 0. A 0 there, 0 there, 0 there. Negative 12 divided by 1 is negative 12. Oh boy. And x-intercept. Oh, I need more space. Oh, I see. This is not moving. Alright. If I set the y equal to 0, it seems I have 2 values. So that is a 4 and a negative 3. Alright. Now, okay. Had to skip a problem. This problem, if I I love that. There we go. If I factor the top, wouldn't these two cancel out? Isn't this saying y equal x minus 5? Well, I know how to graph that. Who's gonna tell me what the domain for this problem is? You could choose any number you want. You can never ever have a negative 6. But negative 6 cancelled out. It makes no difference. Once you restrict a value out of the domain, you can never have it. So even though it's no longer an asymptote, it's not a vertical asymptote, I still have to show it on the graph. Anybody looking at this graph, oh, Oh, with all the excitement, I forgot to label the last one. Wow, what is happening to me? I'm so ashamed of myself. Okay, vertical asymptote x equal -1. So the point is, anybody looking at this could tell, hey, they could tell you what the domain is. X can never be a -1. It doesn't matter what the rest is, but domain is always vertical asymptotes. Y equal x, 0, 0, 1, 1. The graph must pass through intercepts 0, -12, 4, 0, -3, 0. Okay. Here, let's say, wait a minute. I really don't need any of this mess. I know how to graph this. Go down 1, 2, 3, 4, 5, right? Rise 1, run 1. And I'm using a color that's very hard to see. I'm going to write on top of it. And you'll say, wait a minute, that's a line. You're right, that is a line. Why is that a line? Oh, you know that? Yeah, why? It's not an asymptote. So yes, I should have just... There it is, a line. Except one thing. Somebody looking at this could tell you x cannot be -1. Somebody looking at this could tell you 1, 2, 3, 4. X cannot be 4 or 0 automatically. But somebody looking at this graph, do you see there's no way then figuring out x cannot be -6? So this is what you do. You say on this line, if x equal -6, put a -6 there. Isn't that -11? -1, 2, 3, 4, 5, 6. I need to shift this up drastically. I need to expand this line a bit more. So if I go to -6, -11, I will make that an open circle, indicating this is a hole on the graph. Anybody looking at this line will know, well, okay, it's a line. Everything's allowed except x equal -6. So in the event that things do cancel out, you still have to show that on the graph. Anybody looking at a graph will figure out any vertical asymptote is not in the domain. And 34, if I factor the top, that's x plus 5 into x minus 2. The denominator, that's x plus 5 into x plus 3. This cancels out. So 1, vertical asymptote is only one of them, not 2, x equal -3. 2, horizontal asymptote, do you notice the top is dominated by x squared and the bottom by x squared? So wouldn't these two cancel out and you're left with y equal 1? 3, y-intercept, replace x by 0. If I put 0 here or here makes no difference. 0 here, I'll have -10 over -5, which is -2/3, dividing by 5 top and bottom. And if I go for the x-intercept, where does the top equal 0? This cancelled out. There's only one value, a 2. On the graph, x equal -3, well, -1, -2, and -3. Easy to do. Y equal 1, y equal 1, also simple to show. The graph must pass through its intercepts at 0, -2/3, and at 2, 0. I still have -5. I must show it's nowhere here, and it's nowhere here. -5 is going to be a hole on this graph. And if I put -5 in there, what do I get? Negative 5 minus 2 is a negative 7. And a negative 5 plus 3 is a negative 2, 7/2. I'll come back to that. Now let's use some graphs. This is the key to all of these graphs. A graph must start next to an asymptote and must end next to an asymptote. So left to right. Since the graph must start next to an asymptote and end next to an asymptote, the graph will either look like start next to this asymptote or like this. It's one of those two. It can never be both because all of these are functions. How am I going to figure out whether the graph is this or this? Well, a simple way of doing this. If I pick a point in there, let's say x equal to the left of negative 2, let's say negative 3. If the y is positive, it's this because this is where y is positive. If y is negative, it's this piece. I just want the plus or minus. We did this already. A negative, negative 3 minus 1 is negative, and negative 3 plus 2 is negative. 3 negatives, wouldn't that be a negative? So I know the graph must be below the x-axis because y is negative below the x-axis. There it is. Now, again, left to right, the graph starts next to an asymptote and ends next to an asymptote. The graph either starts here, but it must cross through its intercept, or starts here and it must cross through its intercept. I need to pick a test point in here, a point between 0 and negative 2. How about negative 1? Negative 1 there, that's a negative. Negative 1 minus 1, that's a negative. And a negative 1 plus 2 is a positive. Two negatives will give a positive. That means it's that piece. Now, does the graph go up or does it come down? Well, a point between 0 and 1, let's say 1/2. Remember, I just want to know if it's plus or minus. 1/2 is positive. One half minus 1 is negative, and 1/2 plus 2 is positive. One negative is always a negative, so the graph is below. There it is. And the last piece is either a graph that looks like this. How do I know that? A graph starts next to an asymptote and ends next to an asymptote. Or one of those. All what I have to do is pick an x value. X in anywhere in this region to the right of 1, let's say 3. If I put a 3 there, that's positive. A 3 there, that's positive. And a 3 there, that's positive. 3 positives will give a positive. That means the graph is above the x-axis. Positive above, negative below. Now, I know it seems like we're spending a long time graphing this. Things are going to go a lot faster. I'm just taking my time with the first few. How about this problem? Here, the point to the left, it's either the graph looks like this or like this, but I'm not sure. I need a point to the left of negative 2, let's say negative 3. If I put, the top is a 6, which is always positive. If I put a negative 3 right there, negative 3 minus 3 is negative 6, that's negative. Negative 3 plus 2 is negative 1. That will be a positive. So that tells me if y is positive, I'm above the x-axis. There's the graph. Now, the beauty of an intercept. The graph must cross through the intercept. So I have two options. Either my graph starts on the bottom, goes through that intercept, or it starts at the top. But do you see, to reach that intercept, you have to cross the x-axis? Do you notice I didn't get an x-intercept? So there's no way that could happen. You can never cross an axis without an intercept. That piece I get just from the graph. Now, does the graph come back down toward the asymptote, or does it go up toward the asymptote? Again, since I didn't get an x-intercept there, there's no way you could cross that axis. It's right there. The piece to the right, either one of those or one of those. Well, 1, 2, 3. Let's go for x equal 4 as a test point. A 4 in there. 6 is always positive. 4 plus 3 is positive. And 4 plus 2 is positive. 3 positives will give a positive. It must be above the x-axis. Start next to an asymptote and end next to an asymptote. Done. This piece. I start on the left. Well, I need to pick a point to the left of -1. How about -2? And I'm looking at 3x over x minus 1, x plus 1. And -2. 3 times -2 is a negative. -2 minus 1 is -3. That's a negative. -2 plus 1 is a negative. 3 negatives will give a negative. That means the graph is below the x-axis. Does the graph look like this? Or does the graph look like this? I'm going to pick -1/2. 3 times -1/2 is negative. -1/2 minus 1 is negative. -1/2 plus 1 is positive. 2 negatives will give a positive. It's right there. How about this piece? Does this piece continue down or does it go up? 1/2. 3 times 1/2 is positive. 1/2 minus 1 is negative. And 1/2 plus 1 is positive. A negative, that means it continues on. And believe it or not, we're doing the longest graphs. The rest will always be simpler. You'll see. And a point to the right of 1, let's say 2. 3 times 2 is positive. 2 minus 1 is positive. And 2 plus 1 is positive. That makes it a positive. Right there. The last of these types, and after that is smooth sailing, assuming you like sailing. The piece to the left, either one of those or one of those. Pick a point to the left of -1, -4. And here it is. I have, the equation is really -4 over x plus 1, x minus 3, x plus 3. The top is always negative. -5 in there plus 1 is a negative. -5 minus 3 is negative. -5 plus 3 is negative. 4 negatives will give a positive. There's that piece. Now, here's the tricky part. Here, the graph starts next to an asymptote and ends next to an asymptote. It's either one of those or one of those. The reason it doesn't cross the x-axis, I don't have any x-intercepts. So a point will do. -2 as a test point. If it's positive, it's that piece. If it's negative, it's that piece. Put a negative right there. Well, the top is always a -4. That's a negative. -2 plus 1 is a negative. -2 minus 3 is a negative. And -2 plus 3 is a positive. 3 negatives will give you a negative. That means it's below. Here, it's very easy to do. Either the graph looks like this, or do you see if I start on the bottom, I need to cross the x-axis to reach that? No x-intercept, there's no way it could be that. And does it continue and go up toward the asymptote or come down? Well, if it comes down, doesn't it need to cross the x-axis? No x-intercept, there it is. And a piece to the right of 4, let's say a test point of 5. This is always negative. Positive. 5 minus 3 is positive. 5 plus 3 is positive. So that's a negative. And those are the longest. The rest is going to be a breeze. And let's do that. I have two options. The graph either starts above this line or below this line. But the graph must cross through its intercepts. Do you think it's more likely the graph starts down here, go through the first intercept, the second intercept, and head toward the asymptote? Or do you think it's more likely that the graph starts here, cross the asymptote, and come down? Well, we don't cross the asymptote unless we have no choice. Now, the rest of the graph. So left to right. Either I have a graph that looks like this. How do I know that? Starts next to an asymptote and ends next to an asymptote. Or like this. Do you see there's no x-intercept there? So there's no way it could be that bottom piece. It has to be that upper piece. Done. How about here? I have two options. Either I start above this line, but do you see I need to cross that intercept? We don't cross an asymptote unless we have no choice, so we know you start below. You hit that, and you head toward the asymptote. Here, I could start on the bottom, but to reach that intercept, don't you need to cross the x-axis? Not gonna happen, which means I must start at the top. Now, does it continue down? No x-intercept. So it has to end next to an asymptote. It has to go back up. And here, do you think I'm going to start next to this, cross the asymptote to reach that? Or do you think it's more likely I start on the bottom, go through that, and of course it's the bottom. This piece, left to right, well, I must start below to go through that intercept and end next to that. I want it to be a smooth curve. Here, do you see there's no point in you crossing the asymptote, which means we're going to start on the bottom. Now the question is, does it go above and come back down, or does it go below? So I have to check. I have to pick a point. Let's say pick point 1, 2. Just one test point. At 2 there, positive, negative. At 2 positive, and at 2 minus 4 is negative. 2 negatives will give a positive. That means it's right there. And this piece to the right, do you think it's one of those or one of those? Well, do you see I have no intercept right there? So there's no way I can cross the axis without an intercept. So if the horizontal asymptote is not y equals 0, the graph is very easy to produce. How about this oblique stuff? Well, the same deal. Look at the graph. Either I start next to this asymptote and end next to this asymptote, or next. But do you see there's no x-intercept there? So there's no way I could be above. And either I run from this, but do you see here I have to cross the asymptote to reach that? Unlikely. Most likely I'm going to come down and go back up. And here, do you think I'm going to start on the bottom? But do you see to level next to that asymptote, I need to cross the x-axis? Never going to happen. So it has to be this. And you can't have both. It's only one of them. This graph. By the way, I forgot to mention, the number of pieces of the graph is always one more than the vertical asymptote. So, if you have 2 vertical asymptotes, as you see, if you have 2 vertical asymptotes, then you're going to have 3 pieces of the graph. If you have 2 vertical asymptotes, you have 3 pieces of the graph. If you have 3 vertical asymptotes, one more. 1, 2, 3, 4 pieces. 1 vertical asymptote, 2 pieces. Right? Something to keep in mind, keep you in check. So here, when I saw 2 vertical asymptotes, I knew there were 3 pieces. 1, 2, 3. Here, there's only 1 vertical asymptote, 2 pieces. What do you think the likelihood of you starting above this and heading toward the asymptote, but you need to reach those points? Isn't it more likely that you start on the bottom, cross that, cross that, cross that? I want it to be a smooth curve. And the piece to the right, do you think it's here? Or do you think it's here? Start next to an asymptote, end next to an asymptote. It has to be the top because there are no intercepts there. How about 30? Well, the left, do you think you're going to start here and end up here? Or do you think you're going to start here, go through that intercept, and run up? Well, it has to be the top. It's never both. The piece to the right, you're going to start on the bottom, go through that intercept, and level off next to that asymptote. This one we already did. This one, the piece to the left, do you see if I start on the bottom, I have to cross the x-axis to reach that? So it has to be the top. It can be that piece. And do you see here, to go through those intercepts, you must start on the bottom, go through the first, the second, and the third, except one exception. I have to make sure -5, -1, -2, -3, -4, -5, 7 halves. I have to make sure I show that clearly as a whole. -5, 7 halves. Whoever's looking at this will say, well, look, x cannot be 1 to -3 or -5. And here they are. The homework is already in files. It's section 5.1. It's not the one in the book. And I'm gonna upload that in the Canvas assignment itself. You'll see it right underneath this lecture. And that's gonna be 5.1, the handout. I want you to do the number 7 through 35 odd.